Good morning, my dear young friends. Today, I'll be explaining about the role of pH in acrylic emulsion paints. So, this is a very important issue with the most of the acrylic emulsion paint manufacturers. First of all, let us start this session with a simple demo. I'm having this pH paper. It's a very simple card like this. It starts from 1, 2, 3, 4, 5, 6 and up to 14. So the pH range is 0 to 14. It is a wide range, and 0 to 7 is the acidic range, and above 7 is basic range, and 7 is the neutral range. And with this simple strip, we are going to give a demo, show the demo. For instance, let me take water here, and let us take a pH paper strip. Okay, make sure it is not wet. Now I got the water. Let me dip this strip and check the pH of water. So it is almost pale green. Okay, you just don't touch here, just compare the surface. Now the pH is 7. Are you able to follow this? You got the indicator. Okay, right? So this is 7. pH is 7. This color matches. We can take this is water. Being water, the pH is neutral, that is 7. Okay, right. And let me check the lemon. Let me add a few drops of lemon here and check the pH. So we have to mix it thoroughly, and since the lemon has citric acid, it will show the pH in the range of acid. And make sure that is your hand is free from water or any liquid. Now let me remove one strip and dip it here. Okay, now let us check the pH. So it indicates around 6 here. Being a weak acid, it has gone to the pH level 6 from 7. Are you able to follow? This is 6, right? Okay. So since the lemon is a weakly acidic one, that is citric acid is, I think, let me show both. This is pH 7, this is pH 6. Are you able to find out the difference between these two? Okay, right. And now it is indicated in the strip as this is 6 and this is 7. Okay, now let me take another beaker of water and let me add some detergent. Okay, this is a liquid detergent. Now let us check the pH after mixing it thoroughly. So it is expected to be alkaline. Let us check. Now the hand should be free from any water or any solution. Take this, a strip of pH paper, and dip it gently Okay, now you can check the pH is 8. Are you able to follow? Because I have not added any strong alkali, I have taken only the weak alkali, so that is why it is 8. I hope now you can find the difference here. So this is pH 8. This is pH 7 and this is pH 6. Okay, now we have the strip here. This is the pH reference indicator. Let me focus further. Right now, see that is this is 7, this is 6, this is 8. So 6, 7, 8. Okay, right. So this is the way you had to find out the pH of your solution. Okay, now let me talk about what pH is. What is the role of pH in acrylic emulsion? Okay. Let us start this important lecture, that is the role of pH in acrylic emulsion. pH is defined as the power, the potential of hydrogen. It is the power or potential, and that is why we put P and H, potential of hydrogen. Why we prefer hydrogen? Because when you consider an acid like HCl, it releases H plus or it accepts OH minus ion. So this HCl is capable of releasing H plus, and that is why it is called acid. So acidic nature is nothing but ease of removal of H plus. That is how easier the proton or the H plus can be removed from the reagent. So that indicates the strength of that acid. Do you understand this? And basicity means, for instance, a hydrochloric acid is a monobasic acid. It means it can combine with one hydroxyl unit of a base, and that's why it's called monobasic acid. It may give some confusion to you, sir, when it is acid, why you call it monobasic? It means it has the tendency to combine with one base, and that's why it's called monobasic acid. So that is why the acidic strength here, it is given as basicity of an acid. Do you understand this point? So what is the basicity of hydrochloric acid? It can combine with one OH or it can release H plus. It means monobasic. So for hydrochloric acid, it is 1. H2SO4, this is sulfuric acid. This is dibasic because it has got 2 protons. It means it can accept 2 bases. So that is why it's called dibasic acid. So the basicity is 2. Similarly, tribasic acid, orthophosphoric acid, You may wonder, sir, why you are very particular about this pH, because it is going to be helpful to you not only in the formulation of acrylic emulsion paints, but also in the case of any degreasing agent, de-rusting agent, and phosphating chemicals, manufacturing phosphating chemicals, or the processing of phosphating or metal finishing or electroplating. In all these cases, this acid or the control of pH is a very, very important parameter, and that is why I give more weightage today for this pH. Right. Now let us proceed further. Sir, what is pH mathematically? It is nothing but negative logarithm of hydrogen ion concentration. This square bracket represents concentration, or this can also be represented as negative logarithm of hydronium ion concentration, that is a H3O plus. So what do you mean by this hydronium ion? It's very simple, because hydronium is nothing but that is H plus along with the water. I will explain this later. Then just now we discussed about the range of the pH. It is starting from 0 to 14, and 7 is the neutral, and below 7 acid strength increases, above 7 basic strength increases, and near about the 7, before 7, that is 5 to 7, weakly acidic, 7 to 9, that is 8, 9, these are all weakly basic, 7 is neutral, and strongly acidic is 0 to 3 or 0 to 4. Similarly, 10 to 14 is strongly basic. So less than pH 7, pH 7, less than 7 is acidic, greater than 7 is basic or alkaline, and when pH is equal to 7, it is called neutral. So one thing we should understand, increase of pH indicates the increase of basic nature. Decrease of pH indicates the increase of acidic nature. So this is very important. Right. Next. Now I was talking about this base. Base is indicated by the release of OH minus ion, that is hydroxyl ion. And acceptance, it can be represented as in terms of acceptance of H plus, and we have got other terms also, like that is electrons, but I don't bring all these other definitions here. So we discuss whatever we want to confine to the paint technology. Now NaOH releases Na plus and OH minus ion. So OH minus ion released, so it is capable of accepting 1 H plus. It means this is basic nature. So you have to call it acidity of the base. It is the opposite sense. Okay, so what is acidity of the base? It is 1. For example, in case of calcium hydroxide, it is 2. So likewise we have to go. So similar to, since it releases OH minus ion, that is hydroxyl ion, we should know that is POH is given by negative logarithm of hydroxyl ion, whereas the square bracket represents the concentration, that is how much hydroxyl ion is released. Based on that, the pH will be varying exponentially. That is why we put POH is equal to negative logarithm of hydroxyl ion concentration. Now I want to add one more important aspect here, that is you should know about ionic product of water, which is nothing but, let me say, pure water will not conduct electricity, but protonated water, that will conduct electricity. So let me take 2 moles of water and it ionizes to give hydronium ion, H3O plus, which is nothing but protonated water. It means a H2O plus H plus, it means H3O plus. So that's why it's called hydronium ion or protonated water. And normally this can also be represented as H2O undergoes ionization to give H plus and OH minus ion, and this is proton, but the speed of the proton is very high. So it is interpreted in terms of hydronium ion, and that is why we put negative logarithm of minus log of H plus concentration, and this is also indicated as a log of hydronium ion concentration, H3O plus. So either way it can be represented, that is pH can be represented. Okay, right. Now ionic product of water means you got one ion, this is another ion, otherwise H plus ion, OH minus. So two oppositely charged ion. So the product of these ions, that is H3O plus concentration into hydroxyl ion concentration, this together is called ionic product of water. Okay, KW, ionic product of water. Do you understand this? And so we take the negative logarithm on both sides. When we do like this, we are able to get an equation pH is plus a POH is equal to 14, and this 14 is the pKw value. This is called negative logarithm of Kw. So we call it pKw, so its value is 14, and by combining pH and POH we get 14. So when you are able to get the POH, because being an acid, we should get only POH, so that should be converted into pH. So by using this equation, we can convert the POH of base into pH, and that is why we give a single scale as pH only. Are you able to follow? So pH means that is increase of pH from left to right. So increase of pH from left to right, it means what? That is alkalinity increases, that is basic nature increases. And decrease of pH indicates what? Acidic nature increases. Acidic nature increases. So likewise we can determine. Okay, then now let us move to the next concept, that is, sir, we were discussing about the theory of these pH, all these things, but how it is going to affect the paint, particularly the formulation of acrylic emulsion paint. pH is a very crucial factor in the formulation of acrylic emulsion paint. See, normally the optional pH range is 8 to 9, and if it is less than that, what will happen? The stability is affected, the color is affected, the viscosity is affected, the film formation is affected. So these are the major factors that affect the the formulation or the quality of the acrylic emulsion paint. Now let me discuss the first aspect, that is how the stability is affected. See, that is pH is a very important one that stabilizes the emulsion. And if there is any pH deviation from the standard like 8 to 9, there will be coagulation of resins or emulsions, and also results of flocculation. So that lead to what? Settling of pigments, separation into two layers, the clumping of a pigment. Okay, so all kinds of dirty things will happen when the pH is not properly controlled. Do you understand? So I hope you should understand the importance of pH, even though the quantity to be added is very, very low, but it is very crucial. Second point. Now viscosity. So the viscosity is nothing but that is how easily the liquid flows. So in the case of viscosity, when the pH is disturbed, it affects the rheological properties. That is, it will lead to change of pH, thixotropicity, and settling tendency, gelation, etc. Then color is affected. Why? Because it affects the color stability of the pigment, and the pigments are very sensitive to some pH changes, and that is why any change in pH will affect the pigment sensitivity, that is pigment stability, and there will be some discoloration, and you will not get the expected color also. Then now I want to discuss about the film formation, and before that I would like to add one important point. Now film formation, the pH deviation affects the coalescence. Coalescence means the moving of these polymer particles to form a uniform stretch of polymer or cross-link network. For example, whenever the paint is kept in a pot, it is available as a linear polymer that is inside the container. When it is dried under various conditions, it becomes a cross-linked polymer. So you should try to understand that drying is nothing but a mechanism of conversion of linear polymer into cross-linked polymer. Do you understand this point? And the flow can be checked by taking the solution standard and bulk, that is batch. So put a drop, a few drops of or 1 teaspoon, small teaspoon full of solution or the paint or the resin, and just tilt the glass plate. This is done on the glass plate, transparent glass plate, and it can be of a postcard size like this. Okay. So you can take this size. This is A4 size. Fold it, and you can make use of a glass plate with this size. Do you understand? This is called postcard size. So you can drop the sample, I mean the standard and the your sample, and just tilt it so it will form a neat flow of liquid. So you can study the film formation beautifully and the dry nature, all these things, and you can check for the presence of any extraneous matters also. Now, so likewise you can test. So this is a flow experiment to test the coalescence, flow, and presence of extraneous matter during the film formation of the acrylic emulsion paint as well as the resin. Now, see, this is the substrate on which you have applied the paint film. So because of the cohesion, that is, cohesion takes place, it is the intermolecular force of attraction. So this is responsible for cross work, that is cross linking. And adhesion, this is another one. So this is the intramolecular adhesion, that is between two different, I mean this is intermolecular, this happens, this attractive force happens between two different surfaces. One is film, another is substrate. So that is called adhesion. So this is responsible for binding of the film to the substrate. Do you understand? So we expect both of these parameters are characteristics of film. One is cohesion, to have a smooth lamination of this paint. Another is they should be tightly bound to the surface. The anchoring of paint film is very important, and that is given as adhesion. So that is why we must establish an equilibrium between cohesion and adhesion. So your paint formulations will affect both. So we need to attain this equilibrium in such a way the formulation should be adjusted. Now, as I already told, this is a cohesion that is leads to film forming, and when the particles are not moving, we add, probably that is when I was discussing the acrylic emulsion paint formulation, I would have used this word coalescent solvents or coalescent agent. So its responsibility is for better flow, brushability, etc. Now the cohesion, if it is stronger than adhesion, what happens? That is shrinking takes place. So it will result peel off also. When adhesion is more than cohesion, there will be breaking of films also. There will be a discontinuity pattern also. So that is why we need an equilibrium between these two important parameters. Then, now you may be interested to know how the pH is adjusted, sir, in acrylic emulsion paint. You can add ammonia, you can add amines in various forms like ethanolamine, triethanolamine, diethanolamine, etc. Then you can add sodium hydroxide, even some caustic, but it should be very carefully handled. And this is the case where when your pH is very, very low, it should be abruptly increased, so you can use sodium hydroxide and thereby you can increase the pH. And when you want to mildly increase the pH, that is between 8 and 10 or 8 and 8.5 to 9.5, then we can make use of such kind of ammonia, where you can increase the pH. It is a weakly basic, and you will get a better dispersion, pigment dispersion also, and it improves the stability and film formation. Then we can add amines like ethanolamine, diethanolamine, triethanolamine. Okay. Then suppose if your acrylic emulsion is too much alkaline, then usually if it is alkaline, it gives a very good water resistance, adhesion and film performance. But if it is excessively alkaline, definitely there will be some efflorescence, like a flower, that is, it will form some wrinkled paint film formations also. So in order to avoid or prevent such formation, efflorescence, you can reduce it by adding citric acid or any organic acids, and thereby you can reduce the pH and remove this efflorescence. Okay, so as I already mentioned, That is, the pH is a very, very crucial factor in determining the quality of paint, especially acrylic emulsion paint. And the same pH is also used in the case of degreasing agent. Degreasing agent in metal finishing or metal pre-cleaning, that is intended for cleaning the oil and the grease. In the case of de-rusting, so this is degreasing. In the case of de-rusting, you have to add acid. So this is base. This is alkaline degreasing. We used to call alkaline AD, alkaline degreasing agent. And this is de-rusting agent, acid. So most of the acid has got the etching property. So oxide layers are removed by this. In the case of metal pre-treatment, okay, for subsequent metal finishing, whether it is electroplating or anodizing or what you call the electrophoretic coating, or even for any phosphate coating or nanozirconia coating. So this kind of a cleaning is required. So before proceeding to paint, I'm talking about now the metals, metal finishing, metal painting, it should be primed. And suppose if it is not required, prime is not required, then you can straight away paint. But this metal pre-treatment chemical is very, very important. Okay, so this can be done either mechanically or chemically. So for chemical, we have got degreasing agent, water rinsing, de-rusting agent, followed by there are phosphating process of different types: iron phosphate, zinc phosphate, manganese phosphate, nickel iron phosphate, trication phosphate. So there are so many phosphating processes I will be discussing later. So in all these cases, pH finds an important role. Do you understand? So that is why I have taken this pH, and I hope that is I will be explaining about other metal pre-treatment and organic finishes in the subsequent lectures. Thank you very much. And if there is any problem with your production, regular production, if you have got any product failure or on-site problem or issues, you can give your comments and I'll try to find out the solution, and we'll develop a case study, and it should be useful to many of young metal finishers and paint manufacturers like you. Thank you very much for your cooperation and patient listening.